Hi, this is going to be chapter 3, the two-dimensional motion. I'm sorry, like I did a mistake here. It should be chapter 3, which is motion in 2 dimensions. Okay, then let's do this and try to understand that motion and what's really the physics about it. Now let's assume here you wanna go, this is of course, as I said, chapter 3, and I plan to go maybe from A to B. Okay, and my A is here, which is my starting point. Let's say here. Okay, and this is A, and there is B here. Now, if I want to go here, I can do the following. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. This is 10 meters. Let's assume 10. Then I did move here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going to be 12 because I am away from here by 12. And that is really the 2 meters. Okay, and then what I can do is I can make 10 meters east or right, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 north or up. Now this is, we can say there is a displacement vector here, and there is another displacement vector here. Let's say this is X and this is Y. There is another way that I can do this, which is by moving over the diagonal. Then I can do this by moving diagonal from A to B, and that is gonna be this one. Okay, then this is, we call it R. If I wish to calculate R is going to be the square root of x squared plus y squared. And this is Pythagorean because remember, c squared equals a squared plus b squared. I can also do the following, find the angle here by tan inverse of the y divided by x. I can say here is going to be, this is 10 meters squared plus 9 meters squared, and that is going to be the 81 plus 100 is going to be 181, and that is going to be the square root, which is 13.5 meters. And I can also calculate the angle. Y is 9 divided by 10, and then tan inverse, the second function, and this is going to give you 41.99, which is like 42 degrees. Okay, then this is really, we can do this, okay? All right, now I will say here that I can replace the two vectors x and y by r, or like I can go x and then y. Then these are really two equivalent vectors. Now, whenever I have a motion that is going to be in 2 dimensions, then I will have here to worry about the x-axis motion and the y-axis motion. One of the good examples on this, it is what is called projectile motion. Projectile motion, when the object is initially fired with a velocity that has a y and x component. Or like sometimes we're going to see that the y component is not going to be there, but like mostly this is the most general one. And this is going to be the trajectory of the object. Then this is the v that I was talking to you about, and that is vix, and this is viy. Okay? Or I might have my object that is going to be fired horizontally like this. Okay, this is, we call it zero launch angle or horizontal projectile. Now this is here, I call it the general case projectile. Then this might be any angle here, and we can have any angle so that we will be able to, figure it out how to, what are really the two velocities, the x and the y. Now, I want to maybe talk more about the motions, and just here, of course, this object is going to take this one. You might have another situation where I will have the object was fired like this. You might have a situation like this. We have so many scenarios here. All of these, we call them projectile motion. Now, something that we need to know that there are two motions here. One of them, we call it horizontal motion. And since we don't have like the forces, and we did not talk about the forces yet, but there is no force because always I assume no air resistance. A is 0, and because of that, the object along the x is moving with constant velocity. Therefore, what I can do is I can actually do the following. I can say, if I wish to calculate the final position of the object, it's the initial position plus the initial ix times t. And just I want you to know that we can say vix equals vx at all the times because the acceleration is 0. We have the second motion. It is the vertical motion. And here, gravity is there. Then AY equals negative 9.8. Why negative? Because like free fall, it is always towards the center of the earth, and we should have a equals negative 9.8 because it is downward. If I'm taking like, you know, my x here, my y here, the positives, okay? Okay, here also it is an accelerated motion, then I will say Vy equals Viy plus Ayt. I can say Vy squared equals Viy squared plus 2ay delta y, and I can say delta y, it is Viyt plus 1/2 Ayt squared. Just I'm giving you to a y to know that this is in the vertical direction. Delta y, it is here Viy plus Vy over 2 times t. Okay, then these are the two equations that we are going to use for projectile motion. Either like I will say is gonna be like the one that is really horizontal launching, or the one that is gonna be the general one. Okay, I'm gonna stop here. I'm gonna make it short so that I know that the recording is okay and it's easy to upload.